Edge designations, CFA level 1, pre-reading, quantitative methods, learning module 1, interest rates, present value and future value. We continue on, we've already done one video thus far, we continue on with video number 2. We were up to the section over here. We've really, just a quick recap, we've already covered present value and future value. Okay, we now continue on with an annuity. When we start with annuity, it's just important to remember, okay, there are different types of annuity, and we speak specifically, okay, to regular annuities. And I'm just going to show you a bit of a picture over here. Okay, let's go over there. And remember, just first of all, just a bit of a summary. What is an annuity? An annuity is a payment, a regular payment that's made, or in fact it could be a regular payment that's received, but it's a regular amount that is continually received. Now, let's work it this way. Let's say, for example, there's time period 0, and there's time period, let's make it time period 5. Let's just say, for example, okay, that a payment is going to be made, an annuity is going to be made in time period 1, time 2, time 3, time 4, times 5. So there's going to be all the various payments made. Now, and obviously the question is going to ask you, okay, you've made 5 consecutive payments. What's the value? And you can see over here straight away, guys, what am I talking about? What's the future value of an annuity? In other words, I make a payment every period. What's its future value? In other words, I pay and I pay and I pay every period. At the end, in the future, what is its value? Now, we differentiate between 2 kinds of annuities over here, guys. Annuity number 1 is called a regular annuity. A regular, and the big difference, only one little difference. Okay, we'll talk about them, but okay. And there's a regular annuity, and then there is an annuity due. Now, a regular, I'm going to just make my regular annuity in red. A regular annuity means that the payments, okay, in my example over here, okay, are 5 payments. There's payment 1, payment 2, 3, 4, and then the very last payment would happen over there. That's a regular annuity. And what would you see about a regular annuity? Payments are made at the end. An annuity due, they're made in the beginning. In other words, payment number 1 is made there. That would be payment 2, 3, 4, and 5. So the difference being that they both, in terms of both cases of annuities, regular and annuity due, okay, is that 5 payments are made per my example over here, but depending on the period. Okay, and we'll talk about annuity due in a second. So let's get rid of that, keep it nice and clean. Okay, now, good news and bad news. Good news, it's all good news in fact. Okay, there is a formula over here. Guys, please don't spend time learning that off by heart. It's a complete waste of your time and your good resources. Okay, we are only going to be using calculators. Okay, so every single time when we get to all the various annuity calculations, yes, I've given you all the calculations that are required over there. Okay, the formal calculations, but guys, please, I don't want you using those. Don't spend your time over there. Rather, spend your time, guys, looking at the calculator work. Okay, now remember, where are we now, guys? Let's just clean up here. We are in regular annuity, future value. Okay, so regular annuity, future value. So I'm going to make payments regularly at the end of every single one of my annuity periods, and I want to know what the value will be at the end. We will do this by an example. Okay, a man decides to set aside $10,000 per year in a conservative portfolio, earning 8% per year. Okay, and he wants to know what the value will be at the end of 10 years. Can everyone see it? And whenever you get these kind of questions, no matter what they are, okay, please always make sure you're able to identify the variable. So he's going to put aside $10,000 per year. That's the annuity. What's another nice name for an annuity? PMT, that's the payment. 8% interest rate per year, that would go under I, interest rate per year on my calculator. And 10 years, that would be my N. If you look over here, guys, method number 1, okay, using the formula. I'm not doing it with you guys. Please don't do it that way. I've given it to you just in case you ever want to do it like that. Please don't. Okay, we move on. Okay, let's look at my calculator work over here. Is everybody comfortable? Okay, 10 is my number of periods. 8 is my interest rate. Okay, payment, and look what I've done here. This is something I wanted to show you just to continue on from what we saw before. Payment, I'll make my payment minus 10,000. Why minus? Remember what we said, and just keep this front and center of your minds. Okay, payment and future value are linked, so you're either going to make them, and this is what I do. I'm going to just teach you how I do it, but there are other ways, of course. I always make those minuses, and then I make my present value a plus. Okay, but doesn't matter which one you do for payment and future value. You can also make those positives if you chose. I don't, but you could. But then make both of them positive, and then you're going to have to keep your present value with a negative sign. So you decide what you want to do. I always go for that approach over there. Okay, plug all your numbers in with my regular annuity, and what do you come out? That the future value is 144,865. What does that tell you? That tells you, and always when you finish the question, just see, does it make sense? And that tells me that if you invest $10,000 per year for 10 years with 8% interest rates, at the end of the 10 years, your value will be 144,865. Okay, we show you the same calcs then on the 12C. I want to skip across regular annuity, present value. We're going to come back to it, but I just want to deal with all the future value calcs first. So we turn a page or two, okay, to page 16 if you are following on in your notes. Annuity due future value. And again, look at this formula. Aren't you glad this is not one that you need to learn? Okay, please don't. Okay, use your calculator. What's the difference over here, guys? Okay, the difference over here, remember what we said, annuity due, or payments are made then when at the, I'm going to write it out specifically like this, BGN. BGN stands for begin. Okay, in other words, now you need to make sure that all the payments that you make reflect that they were made at the beginning of the period. You now need to go to your calculators, guys. You need to go and make sure, if you ever look over there, your button, it's the PMT button. You need to make sure that that PMT button, you go second function, and you see on top of the PMT button second function that it says BGN. In other words, you need to set your payments that your calculator now recognizes that you're doing it at the beginning of the period. Let's look at a calculation example, and we'll look at the calculator in a second. You can see what it says. Find the future value, so I'm still dealing annuity future value, that will pay $10,000 every year for 15 years. First payment is made today. If it's made today, that's called an annuity due 8% interest rate. We have a look over here. There's my formula. Everybody comfortable that my interest rate is 8%, 15 periods from there, and okay. Again, guys, I'm not doing this with you via formula. Please don't learn the formulas. Okay. Let's have a look at using a calculator. We do this obviously via the Texas Instruments. Before you start, guys, make sure you set your calculator to begin mode because it's annuity due. How do we do this? Number one, you press second function. That's your yellow little button on the left hand side. Begin. The begin is, that's the payment button. So you go second function payment, second function. Now you need to go second function, you need to push the set button. Why the set button? Because that's what now sets it back, sets it to begin mode. And again, if you want to unset it from that, you just reverse the process again. And what I always suggest to candidates is, please, once you've done it one time, okay, once you have set your calculators to begin mode, as soon as you've done that, okay, go back and set it back to normal mode again, because often you forget to set it back and it stays in begin mode and all your calculations are done in that mode, which obviously is not applicable for most questions. Okay, look what I do over here, guys. Top of page 17. Okay, and we do all of our calculations, and what does it tell me? I run the calculations that are quite simple. Payment is $10,000 per year for 15 years at a 8% interest rate, and the future value is $293,242. In other words, if I invest $10,000 per year, okay, for 15 years, I can earn 8% interest. Then what would we say? Well, your value at the end of that particular period is going to be worth $293,242. Okay, that is everybody comfortable? Let's stop at this point. Let's do a quick summary. I have done annuity calculations over here, guys, and we have done those for both, okay, what we call both future value calculations. Okay, the first one was a regular annuity where payments are done at the end of the period, and then we done what I call an annuity due, where the payments are done then at the beginning of the period. I mean, that is all future value calc. Let's go back a little bit because we did miss one out, and let's go back and make sure we cover that last little bit, which was what we called regular annuity. In other words, it's an annuity, yes, but it is present value now. In other words, why would we want such a calculation? Let's have a look. Okay, we'll do this by way of example. A man is planning retirement at the end of 2013. That's when he wants to retire. What does he want? He wants to make sure that he receives 20 annual payments of $50,000 every year, annual payments. And the big question is, if we have a look, put this onto a bit of a timeline, it's always easier to see on a timeline. And let's have a look over here. There's time period 0. When is time period 0? First of all, what do we know? That's 2013, and that's also equal to now. It's the present value. And he says, for the next 20 years, time period 1, time period 2, time period 3, etc., 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 all the way through to time period 20. Every year, he wants to receive a payment is equal to $50,000. So in other words, he wants to make a payment today. That's his present value. He wants to make the payment today so that he can earn $50,000 every year. What's the future value? In this particular example, future value is equal to 0 or not applicable. It's not important to me or to my calculations. Is everybody happy with that? Okay, so if I've got all my calculations over here. I know he needs the time period 20 years, 9%. And what would this tell me? This would tell me that if a guy walks into the bank or into an investment house and he says, listen, I'm going to put money down now, okay? And when I put my money down now, how much must I put down now, or the present value, in order to be able to get $50,000 every year for the next 20 years? And they're probably going to ask him, why did you select a period of 20 years? He says that's how long he believes he's going to live for. Okay, let's hope that he was right. Okay, along we go. Let's look at the calculations again, guys. If you ever look at that formula, it's a horrible formula. Don't learn it. Okay, it's not applicable. We are going to do this via our calculators. Okay, and again, let's go into my calculator. Well, there's your formula base. If you wish to have a look at that, let's have a look at the calculator. Okay, what do we see? Payment minus 50,000. Guys, can you see again? I've made the payment a minus number. N 20 years, interest rate 9%. Okay, and what does it tell me? I get to an answer of $456,000, $427. Now, What does that tell me? That tells me if I put this amount of money down, this is the present value, 456,427, what will that entitle me to? That'll entitle me to payments of $50,000 every year for the next 20 years. Everybody comfortable? Okay. Good. Okay, and again, I've shown you the HP12C stuff over there. Do take a look at that if you are working with the 12C. We've done annuity due. I'm going to do one more with you guys. You know what's coming. It's annuity due present value. All that happens now is, and interestingly enough, okay, this is a more common one. Why? Because remember, annuity due is you want to make a payment now in order to receive future payments. But when do you want to receive the payments? Well, typically this will happen with a guy that goes into retirement and he'll say, listen, I'm retiring, but when do I need my first payment to be made? Now. Okay. Why? Because he needs money to live on. So this is not an uncommon calculation. Okay. And again, if you thought I was doing the formula with you, I'm just going to show it to you. I'm not doing it with you. Okay. No need to do that, guys. You're going to use your calculators. Let's look at the example. It's a lovely example. That's one that's commonly asked by CFO. Okay. Not anymore, of course, because it's in the pre-reads. A woman retiring today has got the following options. Look at her options. Number one, she can take $1 million. That's it. Take $1 million today. Walk away. Okay. It's a lump sum. Or she's entitled to 25 payments of $100,000. But when does she get them? First payment starting today. Annuity due. Her interest rate on this particular deal will be 10%. Now, if you just did a rough sum, you'd come to an answer straight away and you say, well, listen, she's getting 25 payments. Wow. Okay. 25 payments, and those 25 payments are what? Okay, $100,000 each. Oh wow, 2.5 million. Now you may think straight away, guys, 2.5 million. Well, let me go for that one because it's worth a lot more than the million. Don't forget, what we're going to do now is we're going to take into account the time value of money. We need to compare like with like. And what does it mean, like with like? If I had to say to you guys, what is this $1 million? Change my color. This $1 million, you receive it today. Am I right? You're receiving $1 million today. Everybody comfortable that would then be my present value, the value of it today. Okay. I need to convert these details, these annuity details, into what? Into an annuity due present value calc. Because if I can do that, I can compare like with like. And I'm now just, all I'm really going to be doing then, guys, is I'm going to be comparing one present value to the other, and we see which one generates the highest number, and of course that's the one I will pick. Okay, so first, as you know by now, it's getting a bit boring, I suppose, the methodology. I always like when methodologies get boring because then I know that it's working. Okay, and there we go. There's your normal one using a formula. We don't do that, of course. Okay, I'm going to take you down here on page 18 if you are following along, guys. Okay, we're going to put this into the Texas Instruments, into your calculator. Let's have a look at the numbers. Payment, guys, it's getting boring now, I know, but when it's boring, I know it's starting to work. Minus 100,000, that's your payment every year. You get that payment for N 25 years, 10% interest rate. Now, what do you see? Wow, hold on a second. That's only worth $998,474. What is that, guys? That is its present value. So the present value over here, 998, is in fact less than receiving $1 million upfront. Not by a lot, okay? But why leave anything on the table? Take the $1 million. Okay. Everybody comfortable? Okay. We've got so at this point in time, guys, what would you tell me? We have dealt with what? Look at my various annuities. We dealt with, we can break them down into future value annuities, the value of the future, and the value now. And in both of those, what did we deal with, guys? Regular annuity, future value, and annuity due. Okay, and then for the present value as well, regular and due over there. Sorry, just a quick one over here. When we looked at this particular example, I think I neglected to mention it, that when we were over here, guys, don't forget to make sure that your payment over there, and you've set it to begin mode. Okay, because remember, it is an annuity due, and the first payment that she will be receiving will be beginning of the period. Okay, and away we go. We've got a new one. It's a perpetuity. That's a fancy word, perpetuity. All that perpetuity means forever, infinite. Okay, and yes, here we do use a formula because it's that simple, isn't it? Okay, what's the value of a perpetuity? In other words, this person is going to receive $1,000 every year for how long? Forever. What's the discount rate? 8%. Look at the formula. It's A. A is the annuity over the rate of return. It's simple, guys. It's really all that you do is you take your annuity as your numerator. There's your $1,000. Your denominator is the 8%, which is the interest rate. Is everybody comfortable? What is the present value? Nice and simple. $12,500. What does that mean? That means if someone has said to you, well, do me a favor, would you sell me an annuity that can generate for me $1,000 every month or every year, whatever it happens to be? In this case, it's a year. Okay, for the rest of my life, yes, you need to pay $12,500 for that. Okay. Now we're going to ask a few little questions as we go, just to make sure we cover all of our bases. Okay, and let's get going over here. We look at the question, and what if the present value is not annual? Okay, in other words, what if the amount that I'm getting is not an annual amount? Well, if that's the case, I just need to adjust the rate from an annual to a quarterly amount. Nice and simple. We'll show you that in a second. Okay, a stock position pays quarterly dividends, quarterly every quarter, of $1,500. The investor has an opportunity cost of 12%, compounded quarterly. Now the question is, how much would this particular person be prepared to pay to earn this dividend stream? Now remember, the 12% is an annual rate, and I'm getting the dividends quarterly. So you can look at the adjustments that we make. We just take the rate of 12% and divide it by the 4 quarters. The rate now is 3%, and the answer then, of course, guys, is how much would you pay to receive this income stream forever? The income stream numerator, okay, $1,500. Okay, interest rate now is 3% because I've adjusted it, because the 1,500 I receive that quarterly, so I need a quarterly rate, 3%, and there is I would be prepared to pay $50,000 in order for the benefit of receiving, okay, $1,500, okay, every quarter. For how long? Perpetuity means forever. Everybody comfortable with that? Okay, we move on a little bit. Okay, next question. How would we calculate the present value of a perpetuity what have we been dealing with up until now? The first payment has always been at the beginning at time period 0. Well, what if it wasn't at time period 0? The first payment was not at time period 0. What I'm going to do is I'm going to show you an example over here. And the question says, find the present value of a perpetuity of $2,000. But remember, guys, look at the question carefully. First payment is made, okay, at time period 5. Interest rate is 5%. Let's look at the numbers over here. So what do we know? Okay, we know that the first payment is made, and it doesn't tell me anything about being an annuity due or something, or any of the payments made whenever, beginning of the period. If that's so, look over here. So let's go. Here's time period 0. Normally, when would I start to receive my $2,000 every month? Normally over there. But now what does it say? No. Sorry, my apologies. I just need to correct that. I don't like that at all. And it's key to this particular question. If it's a normal perpetuity, where would I get my first payment, guys, of 2,000? Over there. Because remember, I always get payments at the end of the year, because it's not an annuity due. If it were, they would have told me. Everyone comfortable with that? This question says the first payment is made when? Time period 5. So let's go time period 2, 3, 4, and 5. Now, if the first payment is made there, is everybody comfortable? When did I pay? Okay, that's the big question. When did this annuity kick in? Well, not here, not in time period 5, because that's when I received my first payment. Everyone comfortable? So when did I in fact pay for this annuity? I paid, I'm going to change my code. Everyone comfortable that I paid for it here? Everybody comfortable? I paid for it over here. I paid for it over there, and then what, guys? I received the first payment there, because it says to me, I received the first payment in time period 5. Is everybody, it's quite vital to this particular question that you've understood that, and it's quite vital that you read the question so carefully each time to make sure you know exactly what you're dealing with. Everybody comfortable? Okay, so we have a look at that over there. Everybody comfortable? Okay, so I bought the annuity in time period 4. First payment on it was made in time period 5. Okay, that's fine. Nice. Let's go and work out some numbers then. If that's all so, how much did I pay for this annuity in time period 4? I paid, well, let's work it out. I paid $2,000 at 5%. So is everybody coming? The calc doesn't change yet, does it? $2,000 at 5%. I paid a total amount of $40,000 equals present value. But present value where? Present value here in time period 4. Everybody comfortable? So in time period 4, I would have had to pay how much? $40,000 to be able to receive $2,000 every year forever at a 5% interest rate. Everyone comfortable with that? Okay. But that wasn't the question. Okay. The question is, what is the value of that here? Okay. And that's easy, isn't it? Because all I do is I know the value over here at time period 4. That's its value there. When do I want it? I'm going to change color. Hopefully we can see it easily. I want the value there. Everyone comfortable? So, in fact, the value that I calculate in time period 4 being its present value at time period 4, for time period 0, that time period value of 4, which is its future, which is a present value, is in fact its future value, isn't it? I want the value here. That's its present value there. That value there is in fact its future value. Interest rate we've got. Time period, what's my time period here, guys, to go from these two? 1, 2, 3, 4. So is everyone comfortable? My n is equal to 4. My future value, which in fact was my present value before, is now $40,000. Interest rate we know is equal to 5%, 0.05. But remember, I'm doing this on my calculator, so I can just push a 5. Remember that. And compute present value. Let's run all my numbers. There's your formula. You know me, I don't like to spend too much time on formulas. You could, but when I do it on my calculator, look at my, sorry, that's still on the formula. Top of page 22, let's look at my numbers. Everyone comfortable with our future value? I hope we've illustrated that adequately for you, but the future value is 40,000. The future value, which in fact, previously it does sound a little bit counterintuitive, was the present value. Now it's the future value. Anyway, everyone happy why I've got 4 periods? If I just take you back over here. Okay, I hope we've shown you that clearly enough. There's the 4 periods. And everyone comfortable why it's not 5 periods? Okay, go through that example again if there's anything that you're missing over there. Okay, interest rate is 5%, compute your present value. What does all of that mean? Let's draw another line again. What does all of that mean? Let me show you. Okay, let's get some clarity. If I put aside $32,908 today, that'll be enough money time period 1, 2, 3, 4. That in time period 4, that money, that 32,908 will have grown to what, guys? At 5%, it'll have grown to what? $40,000. Can you now see over here, guys? Hopefully this is clear now. That is present value. That is future value. Okay, it'll grow to $40,000. What will I do with the $40,000, guys? Oh, I'm going to use that money. I'm going to buy myself an annuity. And what will that annuity do? It'll make its first payment to me in time period 5 and 6 and 7 and forever. Okay, if I take you back, okay, how much will it pay you? Okay, paying you, okay, $2,000 every year for the next forever. Okay, so let's just put that in over there. First payment of $2,000 there, and there, and there, and there, and forever. So guys, can you see, time value of money is not overly difficult, not overly crazy, but you've just got to be able to work with the correct numbers and make sure you're working with the correct numbers to be able to solve your time value of money problems. Everyone comfortable? Okay. Okay, and what we're going to show you some here, so just to recap, there's your HP12C, you know we always give you that, okay, because we can, and see if I can, that what they often do is they just reverse numbers around and play with the numbers just a little bit. Now remember, what is, and I'll just show you the maths again, what is the present value of an annuity that you receive forever? It's equal to present value over, is equal to payment as my numerator, okay, over the required rate of return. Come on, count. What if they now say to you, oh, do me a favor, work out rate of return for me? Remember, the minute you've got over here, and if you look here, how many variables have we got? There's present value, there's payment, and there's rate of return. Now, the minute you've got any of the two, you can substitute and mathematically solve for number 3. So they're saying to you, oh, well, if you've got that formula, which is our stock standard formula, what you can now do is you can solve for little r, which is in fact here, it's my denominator. Well, here I'm going to make it what I'm solving for. Let me show you how to do that. Okay, the security pays cash flows of $2,500. That would be its A in my formula. Present value is equal to 31,250. Work out for me what the required rate of return is. So I'm just manipulating my numbers, guys. You see what I've done? And there's your formula. Because what's my normal formula? My normal formula is present value equals A over R. How do I get R on its own? Well, mathematically you would switch those, wouldn't you? Okay. And just look at you can see the solution over here, nice and easy. I would put 2,500 is my payment, 31,250 is my present value. What's my R? 8%. Okay. And again, you can just solve any which way you like. They're doing it to you again over here. Okay. How do you calculate R on its own? Sorry, A on its own. Well, if you want to calculate A on its own, which is your payment, move your R to that side. Now your formula becomes A, or your payment, is equal to your required rate of return times your present value. I'm not going to do that one with you, nice and simple. But just remember, guys, that whenever you do get these interesting calculations, all that you've got to do is remember, okay, like I've shown you here, when there are 3 variables altogether in this particular example, okay, as long as you have 2, you can always then go ahead and work out the 3rd one. Okay, and there's a calculation for you. I'm not going to spend time with that. We've seen that. Okay, we move on over here. Calculate the present value of a series of uneven cash flows. Whoa, now it gets a little bit crazy. Now the cash flows, you see, when we did this before, now let me just illustrate this to you. When we did it before, what was our assumption? Well, let's look at our inputs. We had N, nice and easy. We had interest rate per year. We had present values. We had payment and future values. Those are what we often refer to, guys. I often refer to them here at Edge as our famous 5. Okay. When we look at the famous 5, payment is a key component. And when the payment in this particular scenario, okay, is the same, what we would call those even cash flows. When those payments are exactly the same, guys, then what would we say? I can use these formulas. Nice and easy, because remember, you've only got one shot, one chance to put in the payment amount. You can only do that if they're all the same, if they're even. Am I right? What if they're not? What if they're not? What do you mean, what if they're not? Here's an example on top of page 24. Can you see that? Time period 1, the cash flow was 1,000 out, 2, $200 in, etc., etc. You can see these are what we would define, guys, as being uneven cash flows. Everyone happy with that? Let's do this by way of example. An investment promises to pay $1,000 1 year from now. Did everyone see that one? $1,500 2 years from now, and $2,000 3 years from now. My interest rate is 11%, and the question is, how much would you pay for such an investment? What investment? Well, an investment that has got these particular cash flows promised to you. And what is this calculation, guys? Well, this is just a present value calc, isn't it? What you're trying to calculate is you want to know, guys, what is the present value over there? Everyone comfortable? Now if these cash flow for year 2, let's say, was also 1,000, and cash flow from year 3 was also 1,000, I will just go and use my PMT function. PMT is equal to minus 1,000, am I right? Interest rate would be equal to 11, N would be equal to 3 years, and I would compute present value. But I can't do that now because the payments are not even, they are uneven. What do you need to do? Ugh, what a pain. Well, I'm going to show you 3 separate ways to do this. Way number 1 would be a bit much more of a manual approach. Number 1 would be what, guys? You should take each cash flow, the $1,000, okay, over there, the $1,500 over there, and the 2,000, and for each and every single one, do a present value manual calculation. This is the worst of the worst, the longest of the long. Do a present value calc over there, guys, for time period 1, time period 2, and then again for time period 3. Do your present value calcs individually and then sum them together, and you'll be able to tell me what. Oh, okay, I'm prepared to pay $3,580 when here, time period 0, in order to receive $1,000 in year 1, 1,500 in year 2, and then yes, $2,000 then in year number 3. But as you can see, that's very, very manual. Another way you can do it, you can see on top of page 25, is I can use my calculator to do exactly those calculations as well, but to do them separately. Cash flow stream number 1, so that $1,000, guys, its present value is $900.90. I could then go and calculate stream 2 of $1,500. Its present value is worth $1,217, and then cash flow stream 3, that was $2,000, guys, and its present value was worth $1,462. Go and calculate, go and sum all of the present values, and yes, you get exactly the same thing, $3,580. And again, it is still a little bit of a manual way of doing it. It's still a little bit long, isn't it? Okay. We come to the real way we want you to do it. Okay, if you look on your calculators, guys, 1 row down and 1 to the right, you've got this lovely function. Okay, it's called CF. Okay, that's the cash flow mode. Okay, so when I'm calculating my present value, I use 2 functions. I use the CF mode, which is the cash flow mode, and I use the button exactly next to it, which is called the net present value calculation mode, which is, that's how I calculate my present value. The cash flow mode is the mode that I use to input all the cash flows into the calculator. Once I've inputted all my cash flows into the calculator, I then use my NPV modes to move forward. Okay. Here's all my keystrokes. Let's have a look over here. Going back to the original example, guys. I start off and I push CF. CF stands for cash flow. Okay. It says to me CFO. CFO stands for cash flow when? Time period 0. No, I don't even want that one at all, because when did my first cash flow of $1,000 happen? When? Cash flow number 1. And now a key component, guys, of the CF or the cash flow mode that you're in. And how do you get into that mode? You just push CF on your calculators. Once you push CF and you're in the cash flow mode, you use your arrow keys to scroll up and down quite extensively. You push that in. CO is equal to 1,000. Everybody comfortable? Okay. What the computer then, or the calculator then asks you is F. F01. What does FO1? FO1 stands for the frequency of cash flow number 1. In other words, how many times do you want the calculator? Because often what you get, guys, is you get the following cash flow profile: 1,000 in time period 1, 1,000 in time period 2, and then 2,000 in the next period. So you can see sometimes there are the same cash flows 2 years in a row, 3 years in a row, and that's why when the calculator now asks you frequency, how many times do you want this 1,000 to be repeated? Here I keep it as 1 because it only happened once, didn't it? But in this case, there I would put input 2. Why? Because I want that cash flow of 1,000 to be repeated 2 times. So it's a very powerful function, this F function. And remember, F stands for frequency. How many times do you want the cash flows then to be repeated? Everybody comfortable? Okay. I then move down to my cash flows number 2. I push in 1,500 for cash flow 2. Again, the calculator asks me, how many times do you want to repeat this? And again, I say only once. Because remember, what was my cash flow profile? Let's take you back. Remember my profile of my cash flows. Here they are. There they are. Everyone comfortable? There they are. So 1,000 in the first period, 1,500 in 2, and 2,000 in 3. So there was no repetitive cash flows. They were all completely uneven. Okay. So then when I come over here, guys, for my third cash flow, I then have to push 2,000 in for cash flow number 3. How often do I want it? Okay, same story, and I move along. At this point in time, all my cash flows have been inputted. Okay, now I go to the next mode, which is the button directly to the right of the cash flow button. That's called the NPV mode. Then it says to me, the very first question that NPV mode asks me is, what interest rate do you want to work with? And I push in 11, and then I say CPT, compute my net present value, and it gives me exactly the same answer of 3580. If we stopped at this point, what would you tell me? We've now seen 3 separate ways to calculate uneven cash flows. Number 1 is very manual, and to work with formulas, we're not going to do that one. Number 2 is to use your calculator, but to use the present value function. In other words, go and calculate the present value. I'll just take you back a page. Calculate the present value of the 1,000, present value of 1,500, and present value of the 2,000. Also seems a bit long, didn't it? The third way we've shown you over here, guys, is to use the cash flow mode. Cash flow mode, you input all the formulas, all the cash flows into the cash flow bank. You push NPV to calculate then the net present value. We then show you exactly the same thing over there, guys, with the HP12C. Is everyone comfortable with that? Okay. And again, carrying on with HP12C. Just for really, guys, again, for those that are not using the Texas. Everybody comfortable? Okay. I'm not going to spend much more time over there. If you are using the 12C, well, there, go ahead. Okay. We move on over here, guys, and this is unfortunately a bit of a difficult one. Okay. What if I wanted to calculate the future value? Because remember, what did I do before? I calculated the present value of uneven cash flows. What if I say to you, now, hold on a second, guys. Here are my cash flows. Look at them. $1,000 in year 0, $1,200 in year 1, $1,500 in year 2. And then I say to you, do me a favor, tell me, what would, if I had to give you all those cash flows and they can earn 10% compounded, what is the value going forward? The value here, not present value, but the value over there. Everybody comfortable? So it's a slightly different, well, it's a completely different question. Okay, everyone comfortable? Now the challenge over here, guys, is that unfortunately this does require, you can only use method 1 or method number 2 over here. Method number 1 is a completely manual method. I've got to go and calculate future values for every year. Okay, and I calculate those future values and I get to 4433. Or I can go and use my calculator again, still fairly manual. I take my first payment, guys, of 1,000 and I future value that. I take my next payment of 1,200, I future value that. I take my third payment of $1,500, I future value that. And then what I do, guys, I sum all of my future values, number 1, number 2, and number 3 together, and I get to an answer of 4433. Okay, unfortunately that's the only really way to calculate it for a future value calc. Yeah. Okay. And how would we do this on using the cash flow keys? Not applicable because we don't have the future value function. When I'm using my cash flow mode, guys, unfortunately on the VA2 Plus, for my cash flow mode, I can only calculate present values, not future values. So yeah, it's a bit of a downer. Okay, there are your buttons if one was looking on the 12C. There we go. Okay, and same story, it does not seem to allow us to do it in a quicker manner than that. Okay, is everybody comfortable with that? Okay, calculating the present values of uneven cash flows if the compounding is not annually like we've looked at up until now. So we're just mixing it up a bit over here, guys. So it's present value of cash flows and the compounding is not annual compounding. What I do over here, okay, okay, horrible. I've got to use this fancy formula over there. Okay. Good news, well, semi-good news. Unlikely to come up with something like this, guys, just generally due to the length of it, okay? But unfortunately, guys, okay, is the cash flow keys on the Texas would not be able to, it'll just take you way too long to do that, okay? And unfortunately, most of the time we need to solve it via this horrible looking formula. And what does this formula do for you guys? This formula does a bit of a conversion. Again, we've got my M over there, don't we? What's my M always, guys? My M is the frequency then of the compounding. Okay, and there's your HP methodologies as well. We are not going to spend time then on that. This one we've done already, interestingly enough. Calculate the present value, and whenever the question says to you, do me a favor, please calculate the present value, you say sure. Okay, that's always a bit of a relief. Why is that? Because you can use your cash flow mode. What's different about these particular cash flows? Well, here's all my cash flows, year 1 till 7, discount rate of 11%. But what's nice over here, there's a whole batch of cash flows, 4 years worth from where, guys? Year 2, 3, 4, and 5, that are all even, the same. For how many years? 4 years. Okay, my first payment, my first cash flow is 500. Look over here. I enter into cash flow. So first and foremost, yeah, I'm not going to make you completely mad over here, but what you can do if you had all afternoon is you could take each cash flow, 500 for period 1, present value it, equal to 450. Okay, cash flow from stream 2, present value it equals $100 equals to 81. Do the whole thing and eventually sum them all together and you will come to $1,987. That's going to take you most of the afternoon. Okay, And you could do that with the Texas using the time value of money calc as well. The way we do it is to use the Texas, okay? But remember what we said, okay? Remember what we said. Let me see if we got it over here. We do top of page 32. Look what you do. Look over here. Okay, so first and foremost, remember, I put my first cash flow in a 500, enter, cash flow 1. What does the calculator ask me? What's your frequency? Only one time. Good. My next cash flow is 100. Cash flow number 2 of 100. Then it says to me, what's your frequency? And what do I put? 4 times. Why 4? Let's go back. I'll show you. We say frequency 4 times. Why? Because remember, guys, it was that particular cash flow of 100 that happened when? In year 2, was repeated in year 3, year 4, and year 5, a total of 4 times. Now when the calculator says F, frequency, how many times do you want to repeat cash flow number 2 of 100? You say 4 times. In other words, cash flows from year 2 to 5. Everybody comfortable? And that's going to save you a whole whack of time. And then you carry on normally with your normal calculations. And yes, you get to exactly the same net present value again. But it just all that this shows you is a little bit of a shortcut that one can use to be able to get to the final net present value. And again, guys, there is your HP12C buttons there for you. Okay. Last but not least, we shan't spend much time over here, but look at the learning outcome statement. Demonstrate the use of a timeline in modeling and using it to solve time value of money problems. Guys, by now I'm sure you're sick of it. I've shown you how to use the timeline throughout this entire class, so I'm not going to spend much time with you. I always do advise my candidates and my students, guys, please, as much as you can, make use, guys, of a timeline. As you can see, it makes things just so much easier. Okay, makes things so much easier. Okay, we have a look over there. Let's have a look, and then I've given you a little bit of an example over there, guys. Okay, do take a look over there. Okay, not going to spend time on that, but as I say, whenever I don't do an example with you based exactly on these notes, I always just request of you, please, if you, when you go over them yourself, just to make sure you cover all your bases and cover each and every example. When there's calculations, guys, please, 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 please don't just look at them and say, looks good, I understand. Do the calculations. Okay. Guys, that then brings us to a conclusion then of this particular learning module number 1. I've given you a lovely summary for you there on page 34 to take a look over there. It just summarizes everything in short form what we've covered thus far, taking you through then to page 37. What I always request of my candidates, guys, is when you are finished with a particular reading, and you'll notice we do this every time, we go right back to the beginning of the particular a learning module stroke reading, and you say to yourself, okay, now let me go and have a look at these learning outcomes. Okay, let's just pick one and make sure, guys, that you are able to do this, because if you can do these once you finish the particular reading, you're in a very good position. Let's have a look. Okay, calculate and interpret the future values. Well, hopefully we know how to do that now. Present values of a single sum of money. Annuities due, present value, series of unequal cash flows. Okay, everybody comfortable with that? Okay, so by the time you finished all of that, okay, hopefully everybody is familiar with how to do that, and it's a little bit easier for you. Okay, but always do come back to the beginning and make sure that you are able then to do that. This then brings us to a conclusion of this particular video. Guys, we will of course carry on the pre-reading section with learning module number 2 that is coming up.